Have you ever wondered how a tiny little seed can somehow end up powering a massive eagle soaring way up in the sky? Well, today, we're going to pull back the curtain on this hidden network of energy that connects pretty much every living thing on Earth. We're going to look at two big ideas, food chains and food webs. And trust me, by the end of this, you'll see the world's invisible engine in a totally new way.
So let's kick things off with a little puzzle. What in the world connects a single blade of grass to a powerful eagle circling way up high? I mean, they couldn't be more different, right? But believe it or not, they share this really profound link, and it all boils down to one thing: energy. Let's follow that energy trail.
To follow that trail, we have to start with the simplest map there is, the food chain. Think of it like a straight, one-way street for energy. It tells a super clear story of who eats whom, and it lets us track that energy as it gets passed from one creature to the next.
Here's a classic example you've probably seen before. The sun's energy feeds the grass. A deer comes along and eats the grass, soaking up that energy. Then, a lion hunts the deer, and boom, the energy is transferred one more time. It's this perfect, straight line. Producer, primary consumer, secondary consumer. Simple enough, right?
It's a really neat story, but is it the whole story? As you can probably guess, nature is just a little bit more chaotic, a little more messy than that. A simple, straight line just doesn't really capture the full picture of what's going on out there.
And here's exactly why that simple line isn't enough. I mean, in the real world, a lion doesn't just eat deer, right? And a deer might eat all sorts of different plants, not just one type of grass. Most animals have options, and that variety is actually what's key to the survival of an entire ecosystem.
So all this variety creates what we call a food web. Now, instead of one single straight line, I want you to picture dozens of lines, all crossing and connecting with each other. It's not a simple path anymore. It's this complex, tangled map of how energy actually flows.
You know, when you see them side by side like this, the difference is just so clear. The food chain tells a simple story. It's easy to follow, but it's pretty incomplete. The food web, on the other hand, is this messy, complex map of connections, and it's that very complexity that makes it a much, much more realistic picture of life.
So why is this so important? I mean, who cares, right? Well, this isn't just about drawing lines on a chart. Understanding this flow of energy shows us the incredibly delicate balance of an ecosystem. These invisible threads reveal that every single organism, from the tiniest bug to the biggest predator, plays a role and totally depends on others to survive.
Okay, you're getting the hang of it. So let's do a quick check. First question, what does a food chain actually show? Is it A, where animals live, B, who eats whom, or C, how plants grow? Take a second to think about it.
If you said B, you got it. A food chain is all about tracking that direct transfer of energy, that simple, linear story of who eats whom. Nice job.
All right, next one's a little easier. Which of these two models is more complex? Is it A, the food chain, or B, the food web?
Of course it is. It's the food web, for sure. Just remember, the chain is the simple, straight path, but the web is that tangled, interconnected map, and that complexity is what makes it a way better picture of the real world. Okay, time for our final challenge. I've got 4 things for you here: a snake, grass, an eagle, and a mouse. Your mission, should you choose to accept it, is to put them into a logical food chain. Just think about the flow of energy. Who eats whom? All right, you ready? Let's trace the path together. Everything has to start with the producer, right? So that's the grass. What eats the grass? The mouse. Then the mouse gets eaten by the snake. And finally, at the top of this particular chain, the eagle swoops down and gets the snake. That is the correct flow of energy. And this really brings us to the biggest takeaway of all. We've just mapped out one tiny little chain, but remember, it's part of a huge, tangled web. So think about this. What happens to everything else if just one of those links, say the snake, just vanishes? Well, the eagle might go hungry. The mouse population might absolutely explode and wipe out all the grass. The whole system can get thrown completely out of whack. And that's why understanding these connections is so incredibly critical. It shows us just how fragile and at the same time, how beautifully interconnected life on our planet really is.